All right, so we're going to go ahead and get started with section 6 from chapter 6. And this section is on solving systems of linear inequalities. So remember that when we're solving systems, we're looking for solutions that work in both equations. In this case, we're going to be looking at inequalities, though. So we are actually going to be using what we talked about in 6.5. We talked about graphing inequalities. Now we're going to be graphing systems. So you're going to be graphing two inequalities on one graph. So if we're thinking, just going to rotate a little bit. All right, if we're looking at systems of these linear inequalities, what we're going to be looking at, I'm just twisting around a couple of things, sorry. What we're going to be looking at is when you're given these systems, it'll be the same thing as the linear systems in the sense that you'll be given two. You could potentially get given more than two, but for now, let's just worry about being given two. So you'll be given two or more inequalities. And again, in this case, you're just going to be given two inequalities. The other thing about this is that's a little different is that the solution for a system of inequalities is different than linear, because for a system of linear equations, you're looking for one point that they intersect at. But for inequalities, remember, we have to shade that whole region. So in a solution for a system of inequalities, our solution's actually on the graph, and it's going to be where, and it is where, the shading overlaps. So again, with the linear inequalities, we are shading, and so we're going to be looking for an overlap in that shading. The first types of questions that you're going to see, they're just going to ask you if something is a solution of the system. Okay, so nothing crazy. We've seen this when we were talking about linear equations, just asking if there's a solution to the system or if something is a solution. So we do the same thing that we did with the linear equations. If they give you a coordinate and they ask is it a solution, all you're going to do is plug it in. If it works, it's a solution. If it doesn't, not a solution. So let's take a look at the first example here. So they're asking if the ordered pair is a solution of the system. So let's say I'm giving you 2, 1, and the system, that's not a bad bracket, but, and the system, again, is going to be two inequalities. So let's have y is less than negative x plus 4, and y is less than or equal to x plus 1. So the question is the ordered pair a solution? So all I'm doing is plugging this in to both. So I have an x value and I have a y value. So let's take a look at the first inequality. So I have y is less than negative x plus 4. So I take my y value as 1. 1 is less than negative 2 plus 4. 1 less than negative 2 plus 4 is going to get me 2. I have to ask myself now, is 1 less than 2? Yes, that works. Let's do the second one. Y is less than or equal to x plus 1. Who would like to talk me through this one? Look at all of you raising your hands as I'm alone in my classroom awkwardly. Oh, Israel, go ahead. Yes, I'm going to plug in my 1 less than or equal to 2 plus 1. 1 less than or equal to 3. Is 1 less than or equal to 3? Who wants to tell me? Jessa. Yes, 1 is less than or equal to 3. Great. So if I know that when I plug these in, it makes sense, what would that now mean as far as my original question, is the ordered pair a solution of the system? What would my final answer be? Trey. Perfect. Yes, it is a solution. Oh, wonderful. Look how awesome we are. Questions? Not that I can answer them. Wonderful. So we are actually, surprised, not going to do anything else on this page, but we are going to continue. Well, sorry, we're doing one more thing over here, but we're not going to do another example like this. We're going to go right into graphing, which I know is everyone's favorite. And you know what? Let's all caps here. Graphing. Yay, graphing. Okay, so for graphing, pretty basic steps as far as going into this. So the first step for graphing is that we're going to be graphing both inequalities. Okay, so we talked in our last section about graphing inequalities. We're going to do the same thing here, but we're going to be graphing both on one graph. We're going to go through and we're going to do our shading. Okay, and then the last piece here is we're looking for our answer. So remember that the answer is the overlap. Okay, so when we're actually like, you can't write, like there's no like coordinate that you're like, oh, well the answer is 1, 1. Like for inequalities, there's so many answers that could make the inequality true. So you're not gonna sit there and list coordinates all day long. Like you want to, like, you're showing it by the graph. And so if your answer is your graph, you want to make it very clear where the overlap is, because that's the answer that I'm looking for. So I'm looking on your graph for a very clear overlap because that's the answer I'm grading. Questions? Great. So let's flip our page. And so we're going to be graphing a system of inequalities. So they're going to say to graph the solution, okay? And they're going to give you a system of inequalities. So let's say that I give you 8x plus 4y is less than or equal to 12. And I give you y is greater than 1/2 x minus 2. So I have my two inequalities, this is my system, and I need to graph the solution. Okay, so first thing is that I need to graph both of these. In order for me to graph them, remember I need it to be in like the y equals mx plus b. I know there's no equal sign, but I need to identify an m and a b. So let's take a look at 8x plus 4y less than or equal to 12. I am not able to get a slope or y-intercept right here because it's not in y equals mx plus b form. Who would like to talk me through what I would do in order to get the y alone? Ooh, Remy, go ahead. Yep. Great, yes, you're right. So I'm going to first subtract 8x from both sides. And then what did you say next, Remy? Great, yes, divide everything by 4. And I am done. So who would like to tell me, based on what I have here, what my slope and y-intercept would be for this inequality? Who's raising their hands right now? Josh, yes. What would you say would be the slope? -2. And Josh, what about the y-intercept? You are right, 3. And Josh, one more. Is this going to be a dotted or solid line? Solid line. Go Josh. Awesome. Okay. So my other inequality that I have here is y is greater than 1/2 x minus 2. What is my slope and y-intercept here? Who wants to tell me? Anna. Yeah. What do you say? Yep. So Anna said our slope is going to be 1/2. Perfect. And our y-intercept is -2. And Anna, tell me, is this going to be a dotted or a solid line? Dotted, you are correct. Great, perfect. So dotted line because it is just a normal alligator mouth. Great. I think that is everything. So let's take a look over at our graph here. So we're going to go ahead and set up our axes. So I'm going to set up my y-axis, set up my x-axis. And so let's go ahead and start with the first inequality. So let's start with the 8x one. So I have a slope of -2 and a y-intercept of 3. So first thing I'm doing is I'm going to plot my y-intercept, 1, 2, 3. And now I need to show a slope of -2. So remember, -2, it's going to go in this direction so that it creates like an n, the letter n for negative. So if it's -2, Remember, 2 is 2 over 1. So up 2 over 1, down 2 over 1, down 2 over 1, blah, blah, blah. And as far as the line is concerned, we said it's a solid line. So I can just go ahead and graph that there. Great. Now, because this is an inequality, though, I'm not done. So I still need to go ahead and shade one of the sides. So can anyone talk me through how I'm going to pick which side to shade? Who's raising their hand? Sean, go ahead. Yes, I'm going to test a point. Sean, pick a point that you want to test. Perfect, Sean. I did the exact same thing. So remember, I'm picking a point either on this side or on this side, not a point on the line. Point on one of the sides. Sean read my mind and picked 0, 0. And so I'm going to test 0, 0. So if I test 0, 0, when I'm testing it, I can plug it into this or I can plug it into the original. It doesn't matter. They're the same. So we'll just do y is less than or equal to negative 2x plus 3. So if I'm plugging in my zeros, 0 less than or equal to negative 2 times 0 plus 3. So I'm going to get 0 is less than or equal to 3. Is 0 less than or equal to 3? Yes. So what does that mean I do? Brianna, yes, go ahead. Exactly right. So what I'm going to do is I'm going to shade that side of the line. So the side line that has 0, 0, I need to shade. Now I kind of purposely, especially for what we're doing here, I kind of like deliberately, I don't know, shade like the lines all in like one direction like this, one direction. Just kind of doing them all because eventually you'll see a crisscross when we graph the other one. And so I do like it to be kind of clear. So clearly this shading is going with this line. So now I need to graph the other line. So I have a y-intercept of negative 2. And I have a slope of 1/2. And that's positive. So up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2. Now, what's the other detail about this line? Yep, you said it, is that it's dotted. So I do want to be very careful when I'm graphing this, just to make sure that it's very clear that it's dotted and not solid. That to me is very clear. If you really want to, you can go ahead and like kind of darken these just to make it extra clear. And of course, I always appreciate people being extra clear about things and showing extra work, right, Trey? Yeah, I know. So if I have my dash line, now I need to decide which side of this line I'm shading. So let's test 0, 0 again. So if I'm testing 0, 0, I have y is greater than 1/2 x minus 2. So 0 is greater than 1/2 times 0 minus 2. 0 is greater than negative 2. Is 0 greater than negative 2? Yes. That means I'm going to shade the side that 0, 0 is on. So I'm working with this line, 0, 0 is here, so I'm shading this side of the line. Now it's very tempting for you to just shade, like keep it inside here, but you need to show everything. So if you're showing this side of this line, that includes everything out here. Okay, so I'm shading everything on this side of the line. Now you'll see that this is why I'm deliberately doing my shading in like a certain direction, because now what you're able to see is where the shading overlaps. So that actually right there is my answer. That overlap is showing me that any coordinate in this area would be a solution to both of these inequalities. It's almost like a Venn diagram, you know, those little like circle things, like where it overlaps in the middle of those circle things, you know, like, I don't know, those things, and it like overlaps there, so that means they're similar or whatever. So that would kind of be like this in the way that this is going to be your solution there. So because I like everything to be nice and neat, the best thing that you could do in a test is literally like have like an arrow that goes to that region that says that that's the overlap. Okay, so it's clear to me what you're referring to. Now on the homework and what you'll be seeing as we're working is they're also going to ask you what would be a couple coordinates that are solutions. So you could say solutions could be, so if they're asking you for 2 solutions, all you're giving is 2 coordinates, and it could be any 2 coordinates in here. So there's like a bajillion answers. But, you know, we can make life easier for ourselves. So a solution could be, and you can pick any point here. So a solution could be 0, 0, because 0, 0 is in the overlap region. It could also be, does anyone want to suggest a point that it could be? Who's going to raise their hand? Sarah, yes, what's another point? Yes, -1, 1 could also be a point. -1, 1 is right here. That's in the shaded overlap. The other thing that they're also going to ask is they might also say, what would not be a solution? So solutions could not be, and so then I'd pick 2 points that would not be a solution. Again, there are a bajillion options. Any point that's not in this area would not be a solution. It could be a point here, point here, point there. Would anyone like to suggest a point? Oh, Jessie, go ahead. Yes, I agree. 0, -4. 0, -4 is right here. That's not in the overlap region, so that would not be a solution. What else would not be a solution? Who have I not called on? Sunny, go ahead. Sunny, yes, 4, 1. 1, 2, 3, 4. 1 right there, not in the overlap region. Again, I could also pick something out here too, as long as it's not in the overlap. What did you say, Sunny? 4, 1. Yes, perfect. All right, so that is actually it, which is very exciting. So that's 6.6. Before I turn my little camera off, I would just like to remind all of you, oh, it's kind of weird if there's nothing on the camera. Just like to remind all of you that there will be a test on all of this the Friday that we got from break. Please do not forget that. And I hope that you all have a wonderful break, and I'll just miss you all so much.